I'm Sig, and I work here at Slalom Consulting as a consultant manager with this guy and that guy. If you have any questions about what we do and who we are and you haven't talked to us yet, feel free to reach out to us afterwards. We'll be hanging out a little bit. I do want to give a quick shout out since Slalom does pay for the food and space and is very gracious with allowing this meetup to happen. The only other thing I'll add is we do have business cards. Feel free to snag those if you want. And with that, I think everybody found the Wi-Fi. And then July, we're actually pushing back a week since if we had it on July 3rd, I figured we'd probably get all of about 2 people.
Yeah, it would just be me and Sig and our people who can show up.
Well, actually, I won't be here. I'll be
Exactly. It would just be Adam. Just be Adam in a room, sad by himself.
He'd be crying, probably right there.
That's right.
So we figured that wasn't nice to Adam. So we moved it back. So Megan Spams, who is in charge of technical recruiting for us at Slalom, is going to be revealing not all, but most of her secrets. So she said she couldn't tell us everything, but she said she'd tell us some. And she's going to be doing a presentation basically on the whole art of the job hunt from the recruiter's perspective. So even if you're not looking for a job, or even if you think you've got the interviewing thing down, Megan will give you a fresh, unique look at what the other side of the table looks like. With that, I will turn it over to this fine gentleman. And thank you very much.
Awesome. Thanks, Sig. All right. Today we're talking about AppSec. We're going to talk, I didn't update this, so we're going to ignore that. I'm Matt. I work here at Slalom. I do a lot of AWS stuff, but also a lot of security stuff. And we're going to talk AppSec today. It's something I'm very passionate about. So one thing I think a lot of people don't realize is applications, your web apps or any other application out there is essentially the last line of defense for any attack that's going to be coming through your system. It's going to come through your firewall, your perimeter. Maybe you have a web application firewall that's trying to do some layer 7 defense for you. And then finally, it's your application. If your application isn't properly protected, then, well, you're screwed. So typical SDLC, and I know this is super waterfall, but you have your typical planning and requirements, actually writing the code, unit testing, etc. If we look at adding some security into this, there's a whole lot of crap you can actually add here. Anything from developer training to determining what your compliance requirements are, adding some testing tools like static and dynamic testing into your CI/CD pipelines, penetration testing after it's out, and then continuously assessing your application once it's actually out in production. So if you wanted to make this agile, of course you could, but there are a whole lot of things you could actually be doing, and certainly I don't think I've ever seen any organization do all of these, but there are certain things that you can add into your software development lifecycle to help make you more secure. So when we think about web application development, we think about the developer mindset, which I was a developer for 10 years, so all of these really resonate with me. Like, I take the requirements, I turn it into code, I test it at Happy Path, I'm like, great, ship it. And I'm always very limited by scope and time. It's not like, oh yeah, sure, take another year for this feature. That never happens. And my application was always like my child. I didn't want to hurt it by giving it bad inputs or, I never wanted to see a stack trace because it would have made me sad. Whereas if you think about the hacker mindset, they thrive on breaking things. If you're thinking about if you think outside of like the penetration testing world and like a real like nation state hacker or just somebody that likes to break stuff for fun, they're not really typically limited by scope or time, so they have time to do their investigation and really figure out what's wrong with your web application. They're also typically very skilled, at least if they're going to do this for long. So if you think about an AppSec person, their developer mindset plus hacker mindset, and I conject that makes them a masochist. So one of the things I think is super important in security in general, and even more specifically in application security, is defense in depth. So you've probably, if you've ever been to any security conference, you've undoubtedly seen this picture of a castle that has, it's surrounded by water when the tide is up, and then, the perimeter wall to keep some people out, and then all the poor people down at the bottom to, be slaughtered before they actually ever get up to the castle to get whoever's inside the castle. So when you take that same approach into application security, there's stuff you can do at the front end, but you can, of course, especially in the days of modern front ends, we're using Angular or React, you can certainly bypass everything on the front end, go straight to the API. So there's a whole lot of stuff you can do at the API level, as well as the server-side component. For instance, content security protection headers are great. CORS, cross-site request forgery protections, HSTS for HTTPS, et cetera. So lots of protections you can do after you get past the front end. The front end, obviously, client-side validation, cross-site scripting prevention, et cetera. And then as you move back, you notice input validation and sanitation is at almost every one of these, as well as logging. Mostly because I come from a world where every one of these things should be modular and they could be pulled out and put somewhere else, theoretically, although probably never happens. You don't want to ever rely on the front end or just the very perimeter side of your web application to handle that sort of protection. Then lastly, down at the data access layer, you want to make sure you're encrypting your data. Maybe you're doing some limitation on the number of rows that can be returned, so somebody can't do a mass dump of your data if you ever get hacked. And of course, parameterization of your queries and things like that. And we'll talk a lot more about some of these things specifically. One of the organizations that's out there, and maybe you've heard of it, maybe you haven't, is OWASP. It's the Open Web Application Security Project. They've been around for a long time. I think I've been going to their conferences for over 10 years now. But they do way more than web application security. One of the podcasts I listen to is hosted by this guy named Chris Romeo. It's called the Application Security Podcast, and he wrote an article once, and he said, OWASP is the hidden gem of the security world, and I think that's absolutely true. But what is OWASP? It's essentially a not-for-profit group that cares a lot about application security, and a lot more than just web application security. One of the things they're most famous for, if you've ever heard of OWASP, you've likely heard of the OWASP Top 10, which is the top 10 most common vulnerabilities that you'll find in a web application. But they also have a whole bunch of other, if I listed all of their projects, we would probably have 40 or 50 more slides. But some of these are some of my favorites, the proactive controls, which is things you can do to be proactive about security with your applications or even your environments. So things outside of your application. Juice Shop is a vulnerable web application that you can use to find vulnerabilities and see what it actually looks like, and you can even potentially go in and fix them. This is a fully, I wouldn't say fully modern. It's pretty modern. I think it's running Angular on the front end, and it's been written in the last 2-3 years. So let's just go with that. And then cheat sheets. So any of the common things you might do in a web application, like session management or authentication, authorization, cross-site scripting protection, et cetera. There's probably a cheat sheet for it, which is just a list of common ways you might protect yourself. So digging a bit into the top 10, and we'll cover each of these specifically, but we'll also go into some examples, and we'll actually use Juice Shop to show what that vulnerability looks like and what the actual hack would be on the web application. So the first here is injection. I think this has been on the top of the list for since the beginning of this list. So 15 years at least. Second, broken authentication, so maybe allowing session hijacking or logging in or being able to access functionality for a different user, et cetera. Sensitive data exposure. Could be anything from in your console you're leaking too much information, or you're actually leaking customer information like BII. XML external entities, which has actually been on this list since 2013 at least, but it's sort of a weird one because nobody's ever really heard of it. But it's essentially using XML to get access to different files on your file system, and that's one of the ones we'll actually look at. Broken access control, allowing users to access functionality and data that they shouldn't. Security misconfiguration, which is like a giant bucket of stuff that people do wrong, like open S3 buckets like we were talking about earlier, misconfigured HTTP headers, et cetera. Cross-site scripting, inherently dangerous, been on this list for a long time. But even on some of the biggest sites you'll find today, like I'm actually at a security conference this week. I watched a guy hack JetBlue this morning using cross-site scripting. Insecure deserialization. This would be like putting an infinite loop in your JSON payload, and then the server actually executing that, which is far more common than you would actually believe. Components with known vulnerabilities. So I believe at a LocoMocoSec this year, which is a security conference in Hawaii that I haven't gotten Slalom to pay for me to go to yet, there was a slide there that said 96% of the code in modern web applications is in third-party packages, which means your developer is actually only writing 4% of your application code. But that means there's a whole lot of code that you didn't write, you don't know what it looks like, and could have some potential vulnerabilities or backdoors. And last is insufficient logging and monitoring. That's pretty self-explanatory. So going through these next couple of slides here, OWASP rates all of the top 10 based upon these 4 categories. Exploitability, which is how easy it is to pull off this, to exploit this vulnerability. Weakness prevalence, like how often will you find this in the wild? They actually use data collected by thousands of organizations to put this together. Weakness detectability, like how easy is it to find? And technical impacts, like if somebody exploits it, how bad is it for you? So injection, the injection vulnerability that everyone talks about is SQL injection. It's certainly been going down over the last 20 years, but it's still there. There's also things like LDAP injection, or I'm sure there's probably 5 or 6 others that are much more niche. But and I'm not going to go through all this specifically, but essentially if you're passing unvalidated, unencoded data to an interpreter of some kind, and that interpreter is executing that code, then you're vulnerable. We've been trying to fix this with SQL for a long time using an ORM, or parameterized queries, what have you. Or if you really like pain, you're going to write your own, validation and escaping libraries. So that is certainly how to prevent. What do these payloads actually look like? This top one here, if somehow you're able to determine that there's a members table, this top one could theoretically drop that table from the database. Bypassing login screens, like if you ever go to any sort of hacking conference, these are like activity number 1 is getting through the login screen. These are a lot of the most common ones, and essentially you're just hoping that they are passing your input straight to the database. So if your username is here, select star from users where username equals, and then single quote. If you end the quote early, and let's say it's this is just an empty double quote or 1 equals 1, it's just going to get the first row in the database. The important thing here is the termination at the end, the semicolon or the dash or the pound sign, depending on what database you're using, to essentially end the query or begin a comment, something like that. You can also typically log in as another user. So since this grabs the top user in the database, you could potentially tell it to log in as another user by using a union, or just start dumping all the data out of their database. And we'll actually jump over here to not my terminal, but Chrome, where I've got Juice Shop loaded up. And I'll zoom in a little bit. So this is the OWASP Juice Shop that I was talking about. We'll actually go into the login page, and I'll open up Developer Tools, which is, of course, tiny. Any idea how to make that bigger? Because Command Plus obviously didn't work. All right. Oh, it does. There we go.
Nice. Good save.
Yeah. You just have to do it separately, apparently. So up here, we've got email. Let's just say I do, let's just look at what it looks like normally. So ASDF, login. So nothing really bad here. You know, nothing I can really look at. Invalid email or password. Let's take it a step further and do a single quote, just because I know that, you know, screws with some SQL. Now we've got a stack trace here, an error, unrecognized token, and it actually tells me what SQL it's actually executing. So select star from users where email equals single quote and password equals the hashed version of ASDF. So knowing that, it would be easy to use exactly one of those payloads we were talking about earlier, 1 equals 1. And if you notice, if I just leave it at that, the and is still there. I get an object, and let's look at the SQL. So it's still doing and password equals that. But if I add a semicolon onto the end, click login. I'm now logged in as admin because that was likely the first user in the database. And that is SQL injection. Easy enough. It's the only exploit I found in here so far, and I'm trying to I'm trying not to go read all of the answers to how to hack everything in here, just because that's not any fun. And back here. Next is broken authentication. So if you've worked in any enterprise environment that's using like Active Directory, you'll know that if your organization's worth its salt, you know, it's going to lock you out if you try to log in 5 times with an incorrect password, or, you know, n number of times. Certainly not infinite. You'll be locked out for a certain number of times. You can't just stuff credentials forever and ever and ever and do like a brute force password attack. If you're storing your passwords in plain text or even encrypted, I would say you're a bad person. If you're exposing session IDs in the URL where they could be tampered with, also a bad person. And then if you're not invalidating your sessions when your users are logging out, leaving them open and available to use by someone else, again, bad person. Lots of stuff you can do over here. This NIST document, I love NIST. They have a whole bunch of guidelines for everything. NIST 800-63B has the latest version of appropriate password policies and controls, which essentially means prefer pass phrases over pass words. Don't restrict length unless you're gonna like overflow your hashing algorithm. Log everything. Lock your users out if they're trying to log in too many times with bad attempts. Do multi-factor authentication. Don't ever ship anything with default credentials, which of course is hard if you're like a router company or something, but yeah. No demo here because this is just like a bucket of ick. Next is sensitive data exposure. This boils down to encrypt your data in transit, encrypt your data at rest. Rotate your SSL keys. So if you're encrypting data, you know, unencrypt it or re-encrypt it periodically so that your SSL key that you know, Sig made on his laptop 10 years ago isn't still the one in use in production today. And use a modern hashing or encryption algorithm. Yeah. This one's a fun one. So XML external entities. If you're familiar with XML, and I might just go to the next slide for this, you'll know that this statement up here, it doesn't really, who cares about this XML? It's boring. this statement up here, entity system file, colon slash /etc slash password, is perfectly legal. So you can essentially specify any file on your file system and pass this into an XML processor. And assuming the XML processor doesn't have any protections against this, it'll actually go get that file. And we'll actually take a look at what that looks like.
Could you do a remote of that?
You could, yeah. So in here under Contact Us Complain, there's a file upload here. And actually the way I found this was actually look through the source here. Main.js, we'll make it nice and pretty. I actually was just searching in here for XML, where I found, okay, we have some upload somewhere that takes PDF, XML, zip files, and that's about it. So I was looking around on the entire site for anywhere to upload files. I just happened to end up here. I typed my message, grabbed this XXE exploit off the web. And what they actually did do on the front end, you notice they're I forget, I'd have to actually go look at the file input, but they don't allow XML files. So you'll see my xxe.xml file, which is super tiny for you guys, is grayed out. But of course, every operating system just allows you to choose all files. So grab my xxe.xml, which is that exact screenshot we were just looking at. Open, and then submit. And then let's go over here. I've got a file upload for 10. And then let's actually go look at my Etsy password file. If I could spell it right. So at the very top, where are we? User database, blah, 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 a bunch of comments. And unfortunately, the farthest I've been able to get it to show me so far is that top level comment. But if you actually look right here, user database, comment, note that, et cetera. So if this were a normal Unix system and didn't have comments at the top, I would get the first line, most likely, of that file. I'm still working on getting this a little bit further, but that is what I figured out so far. Yeah.
Can you show us the XML file that's being uploaded?
Yep. Okay, where is it? It is this one, but I'll actually show it to you in VS Code, for instance.
I trust you.
Sorry, it's like 11,000 levels deep. So it is literally just me specifying that I want a system file, Etsy password, and then the normal XML that one might expect in that particular upload. And I'm sure this would work if I didn't have any other XML at all. So this would work just as fine as well. As long as it's valid XML, that can be parsed. So a lot of different XML processors guard against this already. .NET's usually the best from what I've seen in protecting against this. Yeah, I think any recent version of .NET since like 4.0 will have protections against this. Java's still playing the catch-up game a little bit. It's off by default. You still actually have to turn it on, I'm pretty sure, except for in the very latest version of Java. And then I don't think many people are doing XML processing in Node or anything else. But yeah, certainly something to check for in your XML processor. And essentially all it is let's see, disable XML external entity and DTD processing in your XML processor. So you can see even all the previous versions of SOAP, because SOAP 1.2 is the latest, I believe, were vulnerable as well. So yeah, that's fun. All right, take a drink. Next is broken access control. So if you've ever been to a website where, let's say in the URL it's /pages/12345, and maybe that's your personal profile page that you can edit. And then you change it to /pages/12345/6, and that's another user's profile and you're able to edit it. That's a perfect example of broken access control. Likewise, if you're using things that are not JOTs, or if you're able to actually abuse your JSON Web Tokens, like using somebody else's previously used token, etc., or replaying somebody else's previous session, etc., that is excellent examples of broken access control. There's lots of things over here how to prevent. Certainly things we've been doing for years, like don't do directory listings, fuzz your application a little bit, checking URLs to make sure that one user can't get to resources for another, rate limiting your API so that people can't just constantly spam every possible randomly generated URL. And I see this a lot, and it's because people don't really plan for this access control from the beginning. And a lot of times they're like, oh, the front end handles that, Angular checks the user session based upon something in local storage and determines if this button should be visible, and if it's not visible, then it can't be clicked, and therefore the API can't be called. But on the back end, they're like, the API is like, does the user have a JWT? Does this request have a JWT or an authorization header? Yes. Okay, I'll let them do whatever they want. Security misconfiguration is just a giant bucket of no. And software that's out of date, public S3 access. Maybe if you're running .NET, you're pushing your PDBs out to production, or you deploy your app with full admin credentials to the box, default credentials. This is the catch-all, in my opinion, of this top 10 list. Cross-site scripting, one of my favorites. It's everywhere, even today. More and more people are moving to CSP, Content Security Policy, to help fix this, which is just essentially headers that are served with your application. Obviously, I've got one example where CSP won't help us because we don't use the UI at all. But essentially, if you're not validating your data, if you're storing your any payload and displaying it again, or you immediately execute, something in a search box, etc., those are great ways you would actually do cross-site scripting. And there's people out here that, out in the world, that all they do is think about cross-site scripting all day. And you'll notice some of these get super complicated. It's not just the basics like script alert something like ha ha ha. Like this one is stealing your cookies. You could send that to your other server somehow, or email it to yourself, or there's a whole lot of stuff you could do. But then people started thinking, how could I write one cross-site scripting payload that you could use anywhere? So like this guy here was like, JavaScript : that's a valid URL, or it's a valid something you would put in HTML. And then I'll add some comments. So maybe if it's in a comment block, it's getting rendered in a comment block, that I'll end that comment, and then I can do some other stuff. And then let me end a whole bunch of other areas where this might actually be rendered: title, style, text area, script, XMP. And then I'm going to load an SVG, but that SVG will actually have an onload. So I'm going to execute this JavaScript, and then on mouse over, I'm going to alert, in this case, just the number 1. But this you could put almost anywhere on any page that is cross-site scripting vulnerable, and you would actually get an alert. So people started looking for JavaScript : So this guy's like, oh, I'll make it some like 1999 MySpace looking text, and uppercase and lowercase. But people are starting to use ASCII or the hexadecimal value with and without semicolons. So literally all three of these down below equate to script alert XSS semicolon close script. So this would be extremely hard to catch every single variant of something that lives in a script tag. And we'll actually look at a couple of examples here. Yeah. So if you are in a session in your browser and you've got a login cookie or something in local storage or really anything that is accessible to your browser, you can pick that up and send it somewhere, and then somebody else can use it, right? There was a spec that was coming around called session binding. It mostly is coming from the identity and access management world, where when I'm logged in, anything written to my browser is tied to that browser specifically and can't be picked up and put somewhere else because it wouldn't. The tokens are bound to that browser specifically. But that sort of died, which is really sad. But yeah.
You probably interact with the browser itself too. If extensions are being fired on it.
Right. Yeah, absolutely. So this, we've got a couple of different cross-site scripting vulnerabilities. First is this track orders. And I have a very basic cross-site scripting payload here. And SpongeBob? Oh, yeah. So in this case, iframe source equals JavaScript : alert XSS. And then look, I get XSS'd on this page, and it actually renders my iframe. So that could have something else terrifying in it too. The search box up here, so let's go back to the home page. Oh God, this is so hard to do. Where's my mouse? There it is. Yep. All right, so I've got a search box up here now, which I can type Apple in and just get Apple-related juices, which is, sweet. Or I can paste that exact same cross-site scripting payload in and hit the search button. And oh, look, it's search results, my iframe, and then I get XSS'd again. And then if we think outside of the UI, I've got Postman up over here. Which I'll pull over here, and I'm just going to grab one of my authorization headers here because I'm logged in. Copy that over to Postman.
So JWT token?
Yeah. Paste it. All I've got over here is my bearer and then my JWT for my authorization header.
Make that a little bigger. Will plus work.
Yes. All right, so I've done this a few times already because I didn't want to come in blind, but so I am posting to the products API, and in my description, this app would actually protect me if I were to create a new product, because I tried it, and put this in the description field. It actually encoded it properly, so probably thank you, Angular, for that. But if I go straight to the API and send this payload, it gets sent. I get a successful product, ID 35. We'll reload this page. Maybe not this one. We'll go home, because it was nice and saved it in the URL for me. And then nothing yet, right? You want it. Okay. Just go over to page 3 here because it's in alphabetical order. Look, I get XSS before I even get to that page, and you'll see that I've got my XSS product right here. So yeah, essentially I walk through every single text box on this entire site looking for, just pasting in that simple iframe source equals, and it's all over the place, even though this is Angular. And we'll talk about different frameworks here in a couple minutes. I guess you guys might like to see the slides now. So insecure deserialization. This is actually a pretty cool one. If you've ever done JSON.parse, you're serializing a string into JSON, right? But what I learned a while ago is that this right here is actually valid JSON. What the heck? This is a simple JavaScript function that is essentially an infinite loop, right? So if I grab that exact, where's my mouse? That exact function, and we're actually going to go to the API docs back in Chrome. So everybody's using Swagger these days, right? So /API docs. I happen to look at the order schema right here and see that some brilliant application architect decided that we should pass JSON as a string value as part of this API. So I can actually try that. So I first need to authorize, so I'll need that JSON web token from over here. Take off bearer from the front. So we could absolutely do the same thing in Postman, of course. We're going to try it out. Sorry. Back to Chrome. So you can see they've got order lines data in here already, and it's just an escaped JSON string. I'm just going to replace that with this and execute. You'll see that it says infinite loop detected, but that means it did actually run whatever is here, right? So very dangerous. I don't actually often see people passing JSON as strings as part of API requests, but I'm sure it's out there somewhere.
Oh, I'll jump in.
Yep.
So with that infinite loop, you're just locking the server up.
Yeah, exactly. It would crash.
Okay.
Yep.
So I'll give you a great example of, like, say, a serialized string within a JSON.
Yep.
object, where if I've got, say, like, an array of different maps,
Mm-hmm.
and within that map, I've got an array of custom objects that I want to just put in as a binary block,
Yep.
right? So it's kind of string.
Right.
Or maybe, I don't know. I get thrown this with the bosses. A lot of times they'll put a map or an array or something, they'll put it as a string with no explanation, and they'll just say it one.
Yep. Sure.
It works.
Yeah, of course.
Just fine.
Yeah.
I'm assuming that there's some reason on the back end that they're doing this string form as opposed to passing along as the map or the
Yeah.
array.
You would think. Yeah, you would think.
This is more
Yeah.
mobile application.
Sure.
Right, where I'm not quite as concerned about someone coming in and
Right. To me, everything being passed around could be a primitive value, right? This is treated as a string, but it is executed. And I do think that they are simply using JSON parse because that's vulnerable, if I remember correctly. So there are special libraries out there that don't, they just take your JSON object and they map it to a model, and there's no execution that happens of anything in between. other than interpreting, can I convert this value into this data type?
Well, for context,
Yep.
it's more on the interpreting side.
Sure.
App-wise. Everything I send is not string.
Sure. Okay. Yep.
However, the payloads I get sometimes are a little bit odd as far as what in there is a string, what in there is actually coming as a noun.
Right. Do you ever have to pass anything executable around though?
No.
Because I know in this case they are taking that JSON string and converting it to JSON on the back end to be able to store it. So,
No, and I'm using very much sort of like a Redux style.
Sure.
Like we've got events, we've got states, and we go into a circle pattern, and you're not going to deviate from any defined events that can go into the system, at least from the app.
sure. Yeah. Yeah, perfectly valid use case. It sounds like I would certainly test yourself. Yeah. If we switch back to the slides here, that's not the slides. Here we go. Just another example. These are harder to find. This is Python and YAML. So if you're loading a YAML file using Python, you can actually have it execute. In this case, it's going to launch a subprocess and then run the whoami command. But obviously, you could do something a lot more dangerous. But this is simply Python loading a YAML file, which I think in the past 2 years I've had to do that exactly 20 times for 20 different projects. But right out of the box, if you're just using YAML.load with I think whatever the most common YAML library is, it is 100% vulnerable. Yeah.
I said because I've used that a lot.
Yeah.
Cool. Using components with known vulnerabilities. I think we beat this a little bit earlier where, 4% of your app is the code you wrote and 96% is the code that somebody else wrote. And whether that person is SIG over here that's awesome and publishes nice, clean NPM packages, or the nation state of China that's publishing, backdoors and collecting all of our data as we're using their packages. Who really knows? You can scan packages, and of course, NPM now, for instance, does.
But they have like high severity, low severity.
Exactly. And I think they're just they're monitoring the packages for well-known CVEs, but if you're not following a common exploit pattern, then I don't think it's going to be caught unless somebody does their research.
GitHub is doing this as well when you're checking stuff in.
Oh, nice. So be wary of other people's code. I'm certainly one to use other people's code because I don't have all the time in the world, but it is scary, to me at least. And then insufficient logging and monitoring. I've certainly used programming languages that are less nice than .NET, where I could drop a breakpoint even on a remote server and it stops and I get to know everything. Logging is how we fix things. If something happens, it's how we understand what happens. Likewise with monitoring, if our server suddenly crashes, do we want to know was it because the CPU was maxed out and the server just decided to reboot itself, or do we want to know that Adam over here was doing a brute force password attack and the server finally ran out of memory and crashed. So this is something very, very important in my opinion. Even though it seems like common sense, like some people are like, yeah, we don't really log in production because there's nothing useful. And I'm like, okay, cool.
They don't monitor it either, right?
Yeah. So since this is Modern Web Meetup, I wanted to talk a little bit about the three most common, in my opinion, JavaScript frameworks: React, Angular, and Vue. React and Angular are actually, if you look at these, very, very similar. React does a whole lot of contextual escaping for you. It won't render something without escaping it, etc., unless you use this beautifully named function here, dangerously set inner HTML. Yep.
Never heard of that.
Yeah.
Is it real?
It's a real thing, yeah.
Real thing?
Yep.
I've built many React applications. I've never seen
Yep. There, there are a couple loopholes, like links, right? If you tell React to render a link, there's no way to know whether or not that link is good or bad. And it can even start. It can start with HTTP : / HTTPS : / It can start with JavaScript : So typically, if you're actually rendering links dynamically, like pulling it from a database or somewhere where a user inputted it, or maybe even if you just want to be good and check everything that you're rendering out of a database, for instance, you could do things for checking like, is it in my whitelist of known good URLs that I want to go to, or does it only start with HTTPS or something like that? And then, of course, as with everything, third-party packages may contain their own vulnerabilities. Angular is exactly the same thing. It's got some pre-built-in sanitation and contextual encoding, et cetera. It's got the same exact loopholes that React does. Their function names are less fun. You know, they have the new SCE and everything after React 2, I think. I could be wrong. I'm not a React developer, but they have trust as HTML, trust as CSS, et cetera. So this would bypass any escaping that happens. And then if you look at Vue, it's like a dumpster fire. So it doesn't do anything to protect you at all. Almost done, I promise. This is sort of like a top 10 list of things I would do in every web app. Just things to be thinking about while I'm coding. Validating all inputs, do a crap load of data validation, and put a lot of control, time, and effort and thought into authentication, access control, and session management. Fail securely, so if if your server is ultimately going to throw a 500, don't give the user the stack trace. You know, don't even really tell them that a 500 happened, maybe, and just give them a nice friendly error message that you might know what it means, but nobody else needs to. At least not somebody that works outside of your company. Don't store sensitive information in clear text. Don't store credentials in source code. I think we've seen people getting more and more burned by that lately. Don't put anything sensitive in the URL. Everything in the URL is logged. So it's going to end up somewhere, and somebody, if they have a malicious bone in their body, could do something with it. Practice the principle of least privilege. So not every user needs every piece of functionality or every button or widget. Log failures and sensitive actions. Somebody's making a credit card payment, or somebody's logging in, or somebody fails to log in, fails to change their password, is launching a nuke, et cetera. Log it. If you're mature enough that you can know what's normal and what's not, for instance, like I know I have a spike in traffic at 9 a.m. When all of my employees get into the office. I have a spike in traffic at maybe 6 p.m. when the night shift starts or something. But if you get a spike of traffic at 1:41 p.m., that might be something that you want to know. So start to think about how you might detect anomalies. And maybe start implementing some alerts based upon that. Don't fall out of date. And my background is really identity and access management for quite a while. Centralized authentication and authorization controls. So if you have maybe 10 apps in your product suite, don't approach them all in a completely different way. Think about things like single sign-on or API gateways or some common scheme to help manage things in one way. I think that'll be that'll take you far. Couple tools and resources. This is really less around writing secure. Well, it's detecting the writing of insecure code. SNCC, very cross-platform. It works with .NET and NuGet and Node and npm, et cetera, et cetera. It essentially looks at all your packages and does a bit better of a job than typical like npm. And of course, it's across all these different package repositories. But it's something you can put in your pipeline to help you detect things. OWASP Dependency Check is a free and slightly crappier version of SNCC. Retired.js, again, it looks for JavaScript libraries that should be retired, and dependencies or libraries that are dependent on other libraries and issues with those libraries. We've got a couple of SAS tools here, which is static analysis of source code testing. Anyway, it's looking at your code and comparing it against patterns of known bad code for things like cross-site scripting or SQL injection, et cetera. These are just fancy pattern matchers, but it's nice to at least have that first step of evaluation in your pipeline. GoList Marrow is a nice wrapper around a whole bunch of scripts that you can use to exploit your app, and W3AF is the same thing. And a whole crapload more OWASP stuff. ASVS is like building security into your software development lifecycle. The SAM is very much the same thing. Talked about all of these. DevSlop is another web application that can be exploited, as is WebGoat. iGoat is the iOS version of WebGoat. And then DEF CON Media Server has a whole bunch of crap going back 20 years or so of all of the talks, some of the videos, all the PowerPoint slides, et cetera. And then there's just a collection of more tools here. And I'm, of course, happy to share these slides. And that is it for me. Any questions? Yeah.
Where can we get these slides?
We can post them up afterwards in the meetup channel, so we'll get those out to you hopefully by tomorrow or so.
Cool.
What slideshow?
I'm sorry, that slideshow, the
Meetup.
channel. Sorry, the meetup. Well, actually,
Site, yeah.
sorry, Slack is on my brain, but we don't have a slideshow. We should have a slideshow. No. But yeah, we'll make sure that those get out to you through the meetup. We'll just post the comments for this talk. And then also the same thing with, this is all being recorded for on YouTube, so I'll post that YouTube link to the talk itself as well.
Sweet. Anything else? Yeah.
How would some of these tools compare with something like Metasploit?
Metasploit can be used for web applications, obviously. Metasploit's a very powerful tool if you know how to use it. So some of these are a little bit easier to use and less. These are a lot more single focused than something like Metasploit would be. Yep. Yep.
So I'm fairly unsophisticated at a lot of this, and a lot of times you'll see tools or error scans report things, and everything seems like it's a priority one. Everything's on fire, emergency that needs to be fixed.
Very common problem with scanning tools. Yep.
Yeah. How do you get a sense of like, well, let's say for example you are, hitting some endpoint or whatever, and you get a generic out-of-the-box error message that reveals, what framework is being used
Sure.
in the background.
Yep.
And somebody says, "Oh, this is a huge deal. This needs fixed ASAP." But it seems like that's the case with everything. Like,
Yeah. Very valid. If you want not that, you have to pay a lot of money. So a lot of the open source tools, like everything's, a P1 because you know the framework they're using, potentially the version they're using. Then you can go look at the exploit database to determine what exploits can I use against that. And then at that point, you could get exploited right away, right? So sure, maybe that's high priority. Maybe it's not. I've seen, I was at a client earlier this year where they're like, you used this in the wrong way. And I'm like, this should not be returned in this scan. But ultimately it comes down to, it takes a while to really hone in that rule set on what it should be alerting on and what patterns you should ultimately be looking for and what you shouldn't. If you go over to a tool like Veracode, you get far less false positives, but you're also paying a lot more money than any of the free tools or even some of the cheap tools out there. But very common problem, and there's no real good solution for it there's no silver bullet to be able to say, here, I can just cut that in half by 50%. It's just, that's not how it works.
And kind of a follow-up question.
Sure.
Sorry, if you don't mind. With a lot of software defects in general, in
Yeah.
the code. When it's, a functional problem or something like that, it's really easy to rationalize as a business how to make prioritization decisions based off that. With security, I never know. I never
Yeah.
have a good sense of, is this more important than feature work? Is this more important than whatever?
Right.
What strategies do you have, or what do you recommend to clients?
Do you have an AppSec person?
Well, no.
Then I would start there. Somebody that can essentially liaise the cryptic messages you get from a scanning tool to a developer, and communicate that to the business to say, hey, this is a big deal, or we can just throw that away and not care. But essentially, that's where I would start. Is somebody, it doesn't even have to be a dedicated AppSec person, just somebody that can be a security advocate and understand both things from the security side, the development side, and the business side. Yeah, that's probably not the greatest answer, but that's what I got for you.
So when you secure data at rest, where do you store the key?
Depends on what tools you're using. I work a lot with Amazon, and if you use something like KMS, you have a master key, and then you have data keys. And then the data keys, you actually get two data keys. One is used for encrypting, and you just throw that key away after you're done with it. And then you also get a second key with it, which is it's a key that's encrypted itself that you can actually pass back to Amazon to get decrypted with the master key to get the actual data key to be able to decrypt. But of course, that's Amazon very specifically. I wouldn't say any single tool has the same exact pattern as any other tool. So.
I had to do that with one company.
Yep.
And because it was medical data, we encrypted everything in the database. But where do you store the key? So I just had
Right.
it in the file system.
Yeah.
I realized how poor.
Yeah, you could use something like, what is it, Vault from HashiCorp, Thycotic Secret Server. In the case of Amazon KMS, you can actually just store the decryption key, or sorry, the encrypted data key with the data itself, because you can't do anything with it until you pass it back to Amazon to use with your master key to get the key to decrypt.
So you still need a third party.
Yeah, exactly. Yes, Matt.
Real quick. I'll check. So, comparing JWT tokens between web applications and mobile applications. Just general thoughts.
They can be used in very much the same way. I think JOT tokens, to me, are used wrong in a majority of web applications. People seem to think that your JOT token should be used for session management, which I don't think they should. Coming from the identity and access management world, I think of OAuth and the fact that I should have an access token and a refresh token. The access token is good for maybe a minute, right? And then the refresh token is good for like 30 days. And that is pure authentication.
That's in the JWT.
Sorry, that's pure authorization. Yeah. And I don't use the JWT for anything else, except for maybe when I load up my UI, if I've got a JOT, I'll pull some stuff and build a session, like user's name maybe, their username. But otherwise, I don't care about that JOT. I'll store it somewhere so that I can send it to my API until it expires, and otherwise I'll have a refresh token that I can continually keep refreshing, getting new JOTs, and then using that. And I think if you're using a pattern like that, using it on the web or on a mobile device, it's the same. I think mobile device, to me, is an even scarier world than web, because web right now, you've got two components, really. The front end, which lately is millions of lines of JavaScript that sit entirely in the browser. Any user can go look at any of it. But you still have the back end, and that's sort of a black box that people don't know what's happening back there. Whereas a mobile device, I can connect my Android phone or my iPhone. I can pull my IPA or my APK file on it. I can decrypt it. I can look at exactly everything that's in there. I can see encryption keys, you know, any static text that's in there, et cetera. So mobile, I think, presents a new world of protecting things like private keys because you're,
Well, assuming
yeah, yeah,
assuming I'm not assigning any tokens.
sure.
But I'm still saving session tokens
Yep.
even in eStore.
Yep, that's the right way to do it, yeah.
Um, I don't know, man. I've got this, like, it's all written out and it seems so clear, but I can't help to think that there's something being missed. And I think a lot of that has to do with the refresh stuff.
Mhm.
Whereas I could set that refresh for a very long time.
Yep.
Right? But every time that the initial JWT expires, I go ahead and reinitiate the entire token, which extends that same
The refresh token lifetime, yep,
30-day refresh.
yep.
Right? So in the event that you somehow sneak into that part, like you're
Yeah.
just forever gonna be able to get that 30-day
Yeah.
refresh.
And in the world of mobile, really the only saving grace is hoping that the key store is secure. Yeah. Yes.
Do you have your favorite tools, as, you know, as a user using the browser? Do you have anything that you could recommend for secure browsing?
Secure browsing or like
Like from the user perspective. What was your favorite tool to ensure that you're not subject to some scripting?
I don't know that I have one. I know we use Chrome today. Chrome has a far better developer console, but otherwise I always use Firefox for a multitude of reasons. Some of those are privacy related, not necessarily security related though.
Just to wipe out the session?
That they sandbox a little bit better. They don't share as much data, and Chrome was constantly filling up or taking up all the memory on my machine, which I just hated. So, yeah.
They have some good scripts too that you can put in there. Like we'll look for, it'll tell you every script that's loading when you go to a web page, and you can choose to block it or load it as well. So you know exactly what's going on. I'll look it up. I don't know what it is offhand.
Other questions? No? All right. Well, thank you guys.
We'll be around for a few more minutes if you have any other questions or information or thoughts. Just contact and let us know.
Yep. There's still a bunch more pizza. Like Sig said, we'll probably be hanging out in our like little bit, probably till 8 o'clock or so. So feel free to hang out, ask questions.